Now that you've seen some examples of the chain rule in use, I think the actual definition of the chain rule might be more digestible now. So let me give you the actual definition of the chain rule. Let's say I have a function f of x, and it equals, I'll just use some h of g of x. Right? And you remember all of this from composite functions. So the chain rule just says that the derivative of f of x, or f prime of x, is equal to the derivative of this inner function, g prime of x, times the derivative of this h function, h prime of x, but it's not going to be just h prime of x, it's going to be h prime of g of x. So let's apply that to some examples like we were doing before, and I think it'll make some sense. So let's say we had, let me say, f of x is equal to x squared plus 5x plus 3, all of this to the 5th power. So in this example, what's h of x, what's g of x, and well, you know what f of x is. Well, let's say g of x would be this inner function, So we would say, let me pick a different color. G of x here is x squared plus 5x plus 3, right? It's this stuff. That's g of x. And what is h? Well, h of g of x is this whole thing. So what would h of x be? Well, h of x is just h of x. This is h of g of x, but h of x would just be x to the 5th, right? Because this expression is you took this entire g of x and you put it in for x right here. I think that makes sense, right? If you take this entire expression and you substitute x here for this entire expression, you get this expression, right? And this shows that this is equal to h of g of x, right? If you just take this blue part and substitute for x, you get this entire expression. So the chain rule just tells us that the derivative of this, that f prime of x, and I have a feeling I'm going to run out of space, f prime of x. Well, actually, before I do anything, let's figure out the derivatives of g of x and h of x. G of x, or g prime of x, so let me draw a little line here to divide it out. I know I'm running out of space. So g prime of x is equal to 2x plus 5, right? 2x plus 5, and then the derivative of 3 is just 0, right? And what's the derivative of h of x? H prime of x is equal to 5x to the 4th, right? So the chain rule just says that the derivative of this entire composite function is just, and let me just write it down here. I'm doing this to optimally confuse you. The derivative of this entire function is just g prime of x. Well, we figured out what g prime of x is here. It's 2x plus 5. So it's 2x plus 5 times h prime of g of x. So what's h prime of g of x? Well, h prime of x is 5x to the 4th. But we want h prime of g of x. So h prime of g of x would be, let's see, h prime of g of x would equal 5 times g of x to the 4th, right? And we know what g of x is. It's this whole thing. So it would be times 5, and this whole thing, x squared plus 5x plus 3, all of that to the 4th power. I think I have truly confused you, so I'm going to try to do a couple of more examples. Let me clear this. Okay, so let me write it up here again. So if we say that f of x is equal to h of g of x, then f prime of x is equal to g prime of x times h prime of g of x. So I'll do another example. Let's say that g of x is equal to x to the 7th minus 3x to the minus 3. And let's say that h of x is equal to, let's do something reasonably straightforward. Let's say h of x is x to the minus 10. So what is f of x? F of x is just h of g of x. And this should be a bit of a reminder from composite functions. So let's say h of g of x would just be, you take g of x and you substitute it for x here. So it would just be brown and blue. It would just be this expression, x to the 7th minus 3x to the minus 3rd, and then all of that to the minus 10th power, right? So this is our f of x. And this is, of course, is equal to f of x, right? Because f of x is equal to h of g of x. I know this is very confusing, but bear with me. Maybe you have to watch the video twice and it'll start making more sense. But we want to now figure out what f prime of x is. So f prime of x. Well, the chain rule tells us all it is we take the derivative of g of x, right? So the derivative of g of x is what? That's easy. Or hopefully is easy by now. Derivative of g of x is 7x to the 6th, and minus 3 times minus 3 is plus 9x to the minus 4, right? I just took minus 3 and went down 1. So that's g prime of x. That's g prime of x. And then times, I'll switch to the brown, h prime of g of x. Well, what's h prime of x? H prime of x is, that's easy. That's just minus 10 times x to the minus 11, right? But we want to do h prime of g of x. So instead of having an x here, we're going to substitute that x with the entire g of x expression. So this is just times 10 times something to the minus 11. And that something is just g of x. X to the 7th minus 3x to the minus 3. And there's our answer. F prime of x is the derivative of kind of the inner function, g of x, times the derivative of the outer function, but instead of it just being applied to x, it would be applied to the entire g of x, right? Instead of an x being here. Maybe I've confused you more. Let me do one quick example just to show you that you don't have to kind of do this whole h of g of x every time. So if I have f of x is equal to 5 times, I don't know, minus x to the 8th plus x to the minus 8th, all of that over to the 5th power. So if I want to figure out f prime of x, I just take the derivative of this inner function, I guess I could call it. So that's minus 8x to the 7th, right? Minus 8, because it's just take the negative 8, x to the minus 9th, times the derivative of this larger function. So 5 times 5 is 25 times something to the 4th, right? And that something is just going to be this expression, minus x to the 8th plus x to the minus 8. And we're done. You could simplify it. You could multiply this 25 out and do et cetera, et cetera. Hopefully this gives you more of an intuition of what the chain rule is all about. And I'm going to do a lot more examples in the next couple of presentations as well. See you soon.